Hi guys, welcome and thank you for joining our session today. I'll quickly introduce myself. I'm Tessa from CloverDX and I'm going to be facilitating today. So we've got Branyo Repchek, VP of Product at CloverDX, and he's going to be presenting today. So today he'll be discussing how to effectively migrate data from legacy systems. So before we get going, just a couple of housekeeping notes. If you have any questions, please pop them in the Q&A box and avoid the chat just so we can filter through them and we don't miss any. So all questions in the Q&A box, please, and we'll address them at the end. We are also recording this session, so we'll send out the slides and the video recording via email. So that's it from me. I'm going to hand over to Branyo.
Thank you, Tessa, and thank you everyone for joining me here today. As Tessa mentioned, I'll talk about migration from legacy systems. And this is an interesting topic because legacy systems are something that many organizations have, and they wish they didn't. And they want to migrate away from that as soon as possible. And the principle or the goal is very simple. You have a system that's pretty old. It's been there basically forever. It no longer suits its purpose, and you want to migrate to something new. There are, of course, many different kinds of migration that you can do, and I will specifically talk about the ones where you are migrating from something that's fairly old, meaning that you often have challenging even finding people who understand the system. It might use outdated technologies, which might actually even be the reason why you want to move away from it. And the new system that you have is something that's modern. Frequently, it's cloud-based, as SaaS tools nowadays are very popular when migrating from pretty much anything. And typically you want your new system to provide you business benefits so that you can get better or faster reporting, better data quality, better visibility of your business so that you can operate faster, which generally is the main reason for this, since the business now moves much faster than it used to many years ago, and many of the older systems cannot really keep up with the demands of modern business. One interesting thing about the legacy systems is that since they've been in the organization for so long, they often become critical part of the infrastructure. They cannot really be shut down because they hold critical data without which the business doesn't work properly. So frequently this is your CRM, ERP, billing system, accounting, or anything like that you really need to work. And the migration therefore needs to succeed, because if it doesn't, you end up with something that doesn't allow your organization to work as it should. Throughout the presentation, I will use examples. We've done several projects like this. I've picked one that was a migration of a telecommunications company. They migrated their CRM. And in this case, it was an interesting project because it was actually happening in two steps. The first one was migration from a really old in-house built system, sometime from 90s, of a relatively small number of customers into the current or the system that they had at the time. And then migration of that system into something new. At that point, they were migrating about 6 million customers. So it was not a massive amount of data, but it was not a small amount of data either. As you can imagine, telecommunications companies have a lot of data about their users, and the data model was quite complicated. In all three systems, they had many different entities with a lot of information about everyone, starting from the basic account data all the way to support tickets and the documents and all the other stuff that you are required to keep as a telecommunications company. When you think about how something like this works and what are the challenges that you can encounter, there are basically four areas that I will discuss in the rest of the presentation. The first one is planning and scope changes. This is always an issue, not just with migrations, but with migrations like this. There is a high risk of having a mistake in planning or having the scope changed as the project progresses further. The gaps in knowledge. This is something where, especially if you are migrating to a new system that you don't have, you don't really know the source because it's a very old system. You might no longer have people who designed it or who understand how it works. And then you are also migrating to a new target system that you don't have the experience with using yet. You will get there eventually, but as you are preparing and planning the project, you might not know everything that you need to be the most efficient in the migration. And of course, since you are migrating something that's been there basically forever, you'll have data quality issues. I've never heard about migration that avoided that. And at the end, we'll look a little bit about execution and reporting so that you can keep your business users happy and informed about what's happening in the project. First, let's look at planning and scoping of the project. I'll start with kind of a generic introduction. When you think about how you want to plan the migration process, and you start with optimistic view, you arrive at few, let's say, discrete steps. First, you analyze and discover the data that you have, figure out the scope and everything. Then you extract the data, validate, cleanse, load it into Target. Then you reconcile to make sure that you've loaded everything. And then you are happy and everything is done. The problem is that this is rarely the case. You want the steps to be discrete, but they are not. In reality, many of these steps happen in parallel simply because you either didn't want to do that because it would take forever to do one step and then the other. Oftentimes, you need to work on the analysis as well as the implementation. You do the data extraction at the same time as validation because you might be working over multiple iterations or multiple stages and so on. And obviously, the way the processes go, that influences the other parts of the whole process. So you have kind of a feedback loop and you need to make sure that it works properly. So you need to have a good project manager keeping everything together. Every time when you start a project like this, you start with business specification. I'm pretty sure that all of you have seen documents such as this. They tend to be hundreds of pages long, full of diagrams, weird, complicated tables, full of colors and everything else. And this is typically your input. Given the complexity of these migrations, it's very difficult to create these documents without any mistake. You can be sure that something has been forgotten simply because the system that you are going from is too old or people don't really know it anymore, or simply because it's complicated, right? People make mistakes and there is no automated way to build business specification for you. So what we've learned on several projects in the past is that you should work with business as soon as you can, even while the specification is in the draft form, because they will be working on it usually sequentially, and they'll pick an area from the system and start working on that. And this way, when the technical team is present while this is done, you can help them uncover issues that they might be don't even know or are not aware of, because there might be something in the application they don't have the experience with, or you might work with them and help them understand the target system better. So basically communicate with your business as early as possible, because it can save you quite a lot of back and forth after the specification is finalized, and even maybe saves you change of scope or even project restart or something like that in later stages. The second step that, as I mentioned, is best to do in parallel while this is being created is to do technical analysis. This is basically going into each system that's involved and looking at them in depth to make sure that you understand exactly how they work and what is needed, for example, to connect to each of your systems, to figure out what are the data layouts and so on. Many of these things will be known during the business specification work, but they might not have all the details. And so technical analysis is very important. And usually the output of this is the implementation plan. It might not have a timeline attached, but it will be a technical implementation, for example, saying that you need to migrate this set of data first before you can do another set of data and so on. This is something where it pays off to be friends with basically everyone, especially if multiple systems are involved. You will need to work with all of them, and if you don't work very well with some teams, it's going to affect the project. This is also the first place where gaps in the knowledge of the source system can significantly impact how long this process is going to take and what is the outcome. You can do this on just superficial level, and you'll get reasonable output, but it will probably be off when you get to the actual effort estimates and planning. So it pays off to be really diligent here and make sure that you discover everything, even though basically every business always complains that this thing takes too long. You need to make sure that you don't have your scope cut and you have as much time as you need to analyze all the systems that you need to work with. Afterwards, when you have the business specification and you know how you are going to do that, you need to figure out how long it's going to take and plan the execution. This is something where oftentimes business will give you some sort of deadline that you have to hit, and then of course that means that you either have to assign more resources if you can't fit your implementation into that, or you need to work with business if it's not possible to do it in the timeline that they've specified. In general, this is a very hard part to do because it often is hard to estimate how long it will take to implement something. For simple business rules, it's relatively easy, but sometimes the rules governing the source and target systems can be quite complicated. And since there is no implementation of this migration by definition, it might be hard to figure out how long that takes. Another frequent question that you'll arrive at during this phase is, how do you want to migrate your data? Whether you want to do everything at once, kind of a big bang migration, or you want to do what's called a trickle migration, where you do multiple runs with smaller sets of data subsets, either by domain, or you simply, for example, split it, 500 customers a day or something like that. There are different ways of doing this. Both have their benefits and disadvantages. For example, big bang usually is a little bit shorter, but there's a little bit more risk. If something happens during the execution at the end, you basically have to roll back everything, and that might be quite a bit of work. On the other hand, trickle migration is something that's easier to kind of keep in your head because you are processing smaller amount of data, usually in each run or in each execution. You are loading data that has something in common, for example, one service type or one account type or something like that. So people who are actually doing the migration and reviewing the reports only need to focus on one thing rather than understanding the whole, maybe complicated data set. The implementation and testing usually takes about the same for both, since in the end you have to implement the same business rules, regardless of whether you do it as a big bang or trickle migration. So in the end, trickle usually takes longer, but typically it's lower risk at the end. You just need to be a little bit more careful with the planning and making sure you order your data correctly, which is actually an interesting thing when you think about what do you start with. In some cases, the ordering is kind of natural because you have to do it in a certain way. But in many cases, in many migrations, you can actually pick which data to process first. Whether you, for example, start with the oldest records or you start with the newest ones, or you go by complexity. And typically, when you look at the complexity of the data, especially, for example, when I look back at our migration of the telco system, there were many customers who had very simple services, just maybe one cell phone or one fixed line or something like that. There were quite a lot of customers who had fixed line, cell phone, or an internet or something similar. So again, not very complicated. And this was the larger group of customers. And then there were, of course, few customers who had all kinds of things. They were usually companies or business users, and they had dozens or even hundreds of services. So the complexity, when you look at that, usually you end up with something like this, right? This is a standard bell curve where simple records, you have relatively few of them. Majority of the data will be, let's say, medium complexity, and then you will have some records that are complex, either because of the services that are tied to that or because of the business logic that's attached to them. What's interesting is if you look at how you handle those records is, of course, the problems grow with the complexity of the data. You need to hit more business rules to process more complex data. There is bigger chance of something going wrong. And oftentimes, especially if you are dealing with customer data, large customers get special deals. So the rules get broken for good deals. And this means that oftentimes you'll see like hard-coded values somewhere, weird conditions in your code, especially if this is an in-house system that's been built over many years. You'll see all kinds of interesting stuff in the code when you look at how large customers are handled. One thing that actually helped us a couple times in the past was start with the complex data first. It might seem a little bit counterintuitive, but when you look at it, in many cases, this is very hard to automate. It might be like 1% of your data or something like that. That's really complicated to migrate. And if you wanted to automate it or build exactly the same pipeline like for the rest of the data, you would just spend so much time on doing that that might not be worth it. So start with this, and as you are migrating this maybe in some sort of semi-manual way, you can finalize automation for the rest of the data and it will go smoother. You learn all kinds of weird stuff about your systems while migrating the complex data. You'll learn more about how your target system works. And ideally, of course, you'll validate and cleanse your data so you'll get something better in the end. And this way, you will not have to migrate everything and then at the end maybe fail because you did not estimate some business rules or implement some business rules correctly. Right? So while this is an approach that might not be obvious at the first look, it's something that can help you quite a bit. And then, of course, there's the dreaded scope change. This is something that can happen on every project. It's something that's very hard to avoid. And in general, there are two ways that this happens. Usually, or frequently, it's because you discover something during technical analysis, or even when you work with business on the specification, you maybe discover something is not complete, or you underestimated the implementation somewhere, and you need to change the scope as a result. Usually this is, let's say, the good case, because oftentimes you figure out, especially if you do the technical analysis properly, you only find relatively small things that do not change that much. And when you are doing your estimates, you can factor in these, let's say, known unknowns into your estimates. You can say that, for example, 10% of your time you can reserve for change requests, and oftentimes you'll be in the ballpark, right? It, of course, depends on the projects that you are doing and your experience with those. What is more interesting is, what if business changed their mind? And this is something that you cannot predict at all, and you cannot even predict what they will think of next. They might find a different tool. Instead of a system A, they migrate into system B. That completely changes the project. It's still more or less the same, right? They will tell you, well, it's still CRM, so what's the difference? But it can mean completely rid of everything that you have. So this is something where the only thing that I found works is basically stay in touch with your business and work with them on everything. Keep them updated on everything you do, and also make sure that they keep you updated on what they are doing. This is relatively hard because you basically have no way of forcing them to do that. But if you have good relationships with them, it can be very helpful, and you can see signs of the business changing mind or thinking about scope changes early before you actually get the email saying that you need to do X instead of Y. So coming back to our project, and I've shown you the data flow before, from in-house to current CRM and then to the next one. And after doing all of this, the technical analysis, working with business and everything else, we came up with a plan like this. Basically, this migration was quite complicated because of all the data that was there, large volume and so on. So we knew that it's going to take a long time, and it's basically independent of this part. So we started one work stream that worked on that, and the plan was to do it for about 2 years. The first one was complex because the source system was complicated. It was an in-house application, and it was very old. So we knew that there's going to be a lot of issues with the data. So we planned about a year for that and started working on that in parallel with a huge data cleansing and data quality effort. So that was the plan. And of course, this didn't go exactly as this, and I'll come back to that a little bit later. Let's now talk a little bit about data quality. This is, from my experience, the single biggest issue in most legacy migration projects, or in general in many other kinds of projects, whether it's a migration or data integration. The reason for that, especially for the legacy migration, is data frequently comes directly from users, especially if it's something that's been running for a while. You can be sure that many of the records were typed in manually into the application or into a database or whatever it is. Oftentimes you'll end up dealing with complicated Excel documents full of color where users made notes on the side, reordered columns, or all kinds of other things. And this makes it very hard to properly validate and cleanse your data. And of course, the data itself changes, the processes in the business change as well. And as people come and go, the processes around what they are doing change, they can start using the system slightly differently. Maybe a field called comment was used for actual comments before, but now it's used for an email occasionally because you only have one email field there, and sometimes you need 2 or 3 for a certain person or something like that. So this kind of thing you'll see in the data, and in many cases your business users will know about this, but in some cases they won't, because it simply feels natural to them and they don't think about the data the way you do, because you see the data layout on the low level. And of course, the classic garbage in, garbage out is very true in migration. If you do not validate your data properly, you will suffer at the end, either because the project will not complete properly or simply the business will not function as they want with the new system. And migration is your best chance to fix that. Even if it might be expensive to fix your data properly, you still should try to persuade the business to do that and to invest into this, because having good data in the end can give you very interesting insights into your business. Even if it's old data, it can still be very useful. And there's nothing worse than having a data warehouse, for example, somewhere and saying that the reports are only valid for the last 5 years because the data before that is not good. And so you need to make sure that the systems that work with your data downstream can use all of it, and all of it is valid. And what helped us during our projects in the past was measuring data quality frequently, basically doing that on every step of the process. Before you even start with something, as you are doing your transformations. And so when you have a transformation or mapping from one source table, for example, to another table, you validate your data on input to make sure that it matches the expectation. Then you do your transformation, and then you validate also on output. In some cases, it's easy because some validations can be done, for example, directly in databases, but you don't always go to a database, right? Sometimes you call an API that might be quite permissive with regards to what kind of data you want there. And this kind of validation can help you catch errors in your business logic, whether they are errors from the implementation, so someone typed something incorrectly or didn't test it properly, or they can actually be logic errors coming directly from business. Simply they did not realize that certain corner case needs to be handled in certain way or something like that. And if you don't validate your data, you are not going to be able to find it out. What also helps is having frequent reports, basically after every execution, whether it's in the test or in production later. Provide a report to your business saying what was the quality of the data, so that they can monitor that. This is especially useful if you are doing trickle migrations, where you are doing many runs of smaller batches of the data. You can do kind of regression, data quality testing, or data quality measurement, so that you can monitor as your data quality changes over time, and you will see that it should improve as you get to newer data. It should not really get worse. And this, you wouldn't want that to happen. And if you set yourself some performance metrics and set proper thresholds for them, it can help you decide whether it even makes sense to continue with certain batch of data, or you need to stop and redesign some part of the solution or figure out some fix for the data from your business user or from data owner. Fixing data is basically a chapter of its own. Oftentimes it's very hard to get people to fix everything, since they might not have the resources to do that, especially if you are migrating large volumes of data, or even you might get into internal politics about who owns the data and who can fix it and who should fix it and so on. The best thing to do here is to try to fix your data as early as possible. Ideally, you want to do that in the source system, because that will impact more things than just your migration. Right? The system that you work with might not be your legacy thing. It might be some system on the side, maybe some reference database or something else. And if that is fixed, if you fix that one, you will help other parts of the business as well. But obviously, again, you need to work with system owners and other parts of your organization to get this done. There's a philosophical debate about how you implement your business logic in the end, whether you want to fail on error or keep on going. And both approaches work in different use cases. In some cases, you want to fail fast, meaning first broken record, and you stop the execution, you notify the business that something is wrong, you try to fix it, and then you resume. Or you can keep on going, in some cases, basically filtering out wrong records and providing some report of what's wrong, and then reprocessing just that data. It really depends on what you are doing. And in many migrations, you'll end up doing both, because some parts of the process will work with just failure as early as possible, while others, it makes sense to just try to keep on processing your data and come back to invalid records later. The next step that you'll have to do after you validate everything is map your data. This is another interesting thing, because in this case, this is where the gaps in the knowledge of your applications will start to show really easily. You basically need to figure out how to map entities from one system to the next one. And if you don't really know the old one anymore, because you don't have the documentation, or the people no longer remember exactly how it works or why it works, and the new system might not be something that you have experience with, then it's very hard to figure out proper mapping. And this is in many cases the reason why the scope or the effort estimates often change during initial parts of the project, because as you learn more about the systems that you work with, you might discover some things that you did not know during scoping and planning work at the beginning of the project. And oftentimes, challenge is also in even figuring out how to map it. Even if you know the systems, the representation of the data might be very different. So the business rules governing the implementation from one system to another might be quite complicated. And that then brings its own challenge of how is business going to tell you that? And they are the owners of the data, so they should somehow provide a specification of how to map it. And again, I'm pretty sure that most of you have seen something like I have in the bottom part of the screen. This is a mapping document from one of the projects we've done in the past. It's an Excel document with many sheets like this for different systems. You can see the source here, mapping, data quality, and a bunch of other columns. It goes to like 80 columns or something like that. It's full of color, full of formulas and all kinds of things. And this is the input for your developers to do that. And while this is something that's typically relatively easy to start with, because you don't really need anything, everyone has an Excel, everyone can create an Excel document, this is a relatively quick way to hell, because this is very hard to version. It's very hard to even keep it together. If multiple people work on different parts of this, it's hard to make sure that they do not override each other's changes and so on. This is also what happened to us on the past projects. So we always try to find something else. And in recent times, you can use data modeling tools, data catalogs, and many other tools like that that help you automate this part of the process, that basically will help you store the metadata about your solution, whether it's information about the data layouts in source system and target. In many cases, you can specify mappings. Some applications allow you to do that quite formally. Some will allow you to put in comments or something like that, but it's still better than doing it with an Excel file or something similar, right? You can also have a Word document that works in similar way, but it's not that much of an improvement. Once you figure out how your mapping should work, whether it's provided as an Excel or you get something that's a little bit more powerful than that, you need to build the mapping. And this is where it starts to be quite interesting, because this is where the developers get involved. And in many cases, they have only very limited knowledge of the domain. So they know what they are supposed to do, but they don't know the reasons why things happen that way. For example, because they know nothing about how the services work on the business level. They don't know why certain things are offered to customers and in one way or in different ways and so on. When you are doing migration like this, you'll frequently use tool like CloverDX. This is a screenshot of Clover, how a simple mapping rule or a set of mapping rules work. And this shows actually one or a few concepts that I wanted to mention. First is break it down into smaller parts. You can see that these green components read database tables, in this case 3 tables, and we read into a single table over here and a report over here in another blue box. So this is mapping for just one type or one entity. And you can see that multiple mapping rules are involved in that. We also validate our data over here. And so just as I mentioned before, make sure that you validate your data before. In this case, that's done in previous stage. That's executed before this one, so it's not visible in this process, but it helps to make sure that the data that you get into the process is valid and you get something out of it and it's valid as well. And the documentation is really important, even if you are using a tool like this that's very graphical, where you can see how your data moves and what's connected to what. It still makes sense to tie that in some way to your business specification. In this case, these are the codes from the requirements document from the business, so you can easily just search for that in whatever specification you have and see what was supposed to happen there rather than what's just implemented in the code. And as I mentioned, validation is the important part, and we are doing that over here on the output. So once we compute whatever we need, we deduplicate that because that's one of the business rules. Then we have the validation of the data, and we produce a report. And this is something that's sent to the business every time this process runs. So they know for every batch of data or every run, they know what was wrong, and then they could go back and figure out how to fix it. In some cases, during early runs, this resulted in fixes in business logic even because they didn't consider all the edge cases for some special services. In later stages, we simply found data quality issues that we didn't think of before. So data broken in weird and small ways. And over time, as we were running more and more data, the reports got smaller and smaller, and we basically ended with empty reports because we were able to cover all the possibilities after a while. Now, of course, once you build this, you need to test it. And there are two levels of testing. You can either test with developers, right? So that's the simple testing, whether the thing even works. And then you need to test with your business users. In both cases, the biggest problem I've seen so far is obtaining test data. In many cases, you'll end up with just manually building a bunch of records. You build 50 records, copy paste some dummy values from a table to test parts of your code, but this is typically not sufficient. Most migration projects require complicated business logic with many conditions, many business rules, and to cover all of them, your manually built test data will take forever to create because you'll need to cover every eventuality. The best way is to actually use production data or something as close to production as possible. And what we've seen working very well in the past is anonymizing your production data. You basically take production data, sample it in certain way. You do not need to run everything, but for example, sample 10% or something like that so that you have sizable test data chunk. And then you anonymize that and then use it for development. This step, or rather these three steps, only need to happen once. Right? Unless your data changes too frequently or something, you usually only need to do this once or maybe twice at the beginning of the project and then somewhere before final acceptance testing. So the overhead of that is not too big, and it can help you test your solution much better than testing on a handful of records that someone built by hand. And as I mentioned, you should always test with your business users because they know what's supposed to be in the data in the end. So it's not enough to just know that the solution completes, but rather needs to produce the data that they expect. And as I mentioned before, do these things as early as possible. Even testing on smaller parts of the solution, for example, mapping of a single entity out of 300 that you need to do and so on, so that you can kind of tick the boxes. And once something is completed, you don't have to go back to that. This works very well when you do something like agile methodologies or something in your development, because you usually already split your work into relatively small chunks. And finally, you've tested everything, you've built it, your business is happy with the performance in tests, so you go into the production and you want to execute your migration. Legacy migrations are interesting in that they run only once, and so it's not a migration that you repeat, or hopefully you don't have to repeat it, you just do it once and then it's done. And therefore that single execution is critical. It needs to work well, and if you've done everything properly and you haven't had any issues, it should it should be fine. But in here, just as before, communication is the key. You need to make sure that the business is notified of every change that you are doing, or every problem in your execution, and kept updated with reports and so on. This will make them happier, and if you need to do something with them in the future, they will help you because they know that you are trying to give them what they needed. And detailed reports frequently are used during development because they help you figure out the problems. And the same reports, especially if your business worked with them before, will help you make sure at the end that your production data is okay. And frequently for this kind of projects, we also do what we call hypercare. This is basically an extended support during the execution of the migration at the end. Usually, for example, you can have like 24/7 support or some extra people on support so that if something happens, they can fix it very quickly, especially if the system is something that that the business requires to operate. It will be critical to resolve any issue, even if small issue, to resolve it as quickly as possible. Now let's go back to our project. And so this is what I've shown you before. Our nice plan of having basically 2 work streams, one that took about, or that was supposed to take about a year, and another 2 years. And this was the data flow. Well, of course, it didn't go as planned, since this happened to us. After several months in the project, we had a project restart, simply because the business changed their mind. There were some technical reasons that helped that, but in the end, it was their decision to also include other systems in the migration. So we started again. This obviously had quite significant impact on the project because we were supposed to also work with additional target systems that were not in scope of this migration at all in the beginning. So everything got more complicated. And in the end, everything worked fine, except the original deadline, it was not possible to keep that. So the first part of the project grew to about twice its size, and the larger migration grew by about half to about 3 years. And so this is what you'll often see in these kinds of projects, simply because even during the execution or during the analysis, you'll figure out something that you did not expect, and you'll have to replan that. Now, if you look a little bit about how we did this and what tools we used, the tool we used for the migration of the data and for implementation of the business logic, the validation, everything is CloverDX. It's a data management platform that's been built to help you work with pretty much anything. The flexibility of the tool helps you work with bespoke systems. That frequently is very useful when you are doing legacy migrations, because oftentimes you don't really have any vendor that can help you, and the system might be unsupported for years or no longer have internal knowledge about that. We can easily support complex scenarios with messy data, and the tight deadlines can often be accomplished by effectively using the automation that the tool allows you to. Our goal when designing CloverDX is basically to solve 100% of a problem. So we always have a solution that you can use. It's not just 90% that's typically easy, but also the 10% that's very hard, like the complex customers that I've shown you at the beginning. We are able to implement that as well, and to help the business migrate that data, even though the business rules governing that were very complicated. The architecture of the tool is very open. It allows you to easily connect with pretty much anything that you need to. You can also cooperate with third-party services, whether you control your instance through an API or something like that, so that you can very easily integrate it into the large infrastructure. And for any migration, the automation is the key. So you need to be able to automate every part of the process, whether it's the data collection, the migration itself, reporting, and even things like watching whether the processes are finishing on time, and reconciliation, and so on. All of that can be easily automated in Clover. And that's everything from me. Back to you, Tessa.
Brilliant. Thank you, Branyo. We will take questions now. So if you do have any, please just pop them in the Q&A box. But we've had some in so far, so I'll shoot them over. So first up, from Amitava, sorry if I've butchered your name, but That's how I see it pronounced. Okay, so is the assumption that data awaiting migration on the old system can change during trickle migration? And does that mean the business has to support 2 systems during trickle migration?
It really depends. But for example, in the telco case, yes, that was what we had to do because the system, or rather both systems, the old one, the legacy one in-house system, also the current CRM, both of them were live. And of course, you cannot stop the business. You cannot tell customers, we are not accepting new customers for 2 years now because we are migrating our systems. This was also one of the reasons why we went for trickle migration in the end, because we knew that once we designed the system to process data in batches, we can just keep reprocessing new records as they are added. And once we catch up with where the data is now, the migration will be finished.
Okay, great, thank you. And a question from Catherine. What are some common tools to use to display mappings or work through the posters like this one shown? Are some tools more in demand than others? I recently saw a job opening. I had the experience with the required phases, but not as much with the tools, which are newer.
All right, thank you for the question. That's an interesting question. There are a few ways of approaching this. Either you can pick something that's very generic, for example, even like Visio or other diagramming tools that allow you to design the process on a high level, but they don't have any execution or any functional part. If you want to get to that level, like for example, if I go back to the screenshot over here, right, to this level, you will have to use a data integration tool. This screenshot is from CloverDX, which is the platform that we provide, but there are other tools on the market that can do something like this as well. And they tend to look in similar way, where you have basically boxes that represent certain functions like reading from a database or filtering and so on, and you build it out basically by connecting them with arrows. Different platforms have different benefits for, for example, how complex mappings you can create and so on. And if you'd like to know more, we are doing live sessions with Clover. One of them will be tomorrow. I'm not sure, Tessa, exactly what's the time, but we'll show you what this looks like and how it works. So you'll see a tool like this in action.
Yes, I will share the link in the chat in a second. There's a follow-on question from Catherine here. Please explain Agile and how this fits in with the processes here, if possible. Again, I've experienced with the phases, but organizations never called it Agile per se.
Okay. So the way that Agile relates to this is actually relatively simple. Basically, when you are building your migration code, if I go back to the beginning, I think I have a slide about that, where you need to start somewhere, right? And you need to split your work into smaller chunks because you need to test it in some way. So for example, in normal Agile, like Scrum or something like that, you designate your sprints to be, let's say, 2 weeks long, and each sprint is supposed to have a result. And so if I go here to this, so each sprint is supposed to have a result. And basically, when you go to the business and tell them about their implementation, you need to communicate that you'll have some partial result, let's say, every 2 weeks. It might be just mapping of a single entity, or first 2 weeks might be generic framework for reporting or something like that. You need to agree on smaller goals and you just complete them one at a time. And after every iteration or after every sprint, you just present to the business. And that helps you in multiple different ways. On one way, it helps the business see that something is happening, right? So it's not like after the analysis, you stop working with them and you come back a year later saying that, well, my solution is finished, let's test it. But rather you continuously work with them. And as you do this, you learn more about how they work and what they are looking to implement, right? So you'll get more domain knowledge because you'll frequently cooperate with them, and they'll learn more about how you work. So the cooperation will improve over time, and especially if it's a longer project that will go, for example, for a year or two, like the one that we've had, this will help you quite a bit when you get to the actual testing at the end of the implementation, because the business will know you and you will know them.
Brilliant,
Yeah,
thank you.
Does that make sense?
Yeah. Okay, so another question from Cliff. Does CloverDX have ability to pull data dictionary from data modeling tools like Irwin and migrate to target databases?
Yes, we can do that. It's always a specific implementation for what you want to do, right? So there's no like magic button for Irwin or for any other modeling tool in Clover where you just push the button and it will somehow copy the model into the database. But we have, for example, created a project called Data Modeling Bridge for HSBC that does exactly this. It doesn't work with Irwin. It uses a different modeling tool, but it takes the data models and specification of the mapping, automatically translates it into a code that it can then execute.
Okay, brilliant. I'll just wait for you to post a couple more questions in there, but whilst we're doing that, I've just shared some links in the chat. Yes, thank you, Branya. So we've got some webinars that are coming up, and the next one is how healthcare tech and insurance companies are solving complex data challenges. So that's on May 25th. And then the one after that is version control and managing teams in CloverDX. So those that are either customers or more familiar with CloverDX, that will be a great one to come along to, and that is June the 3rd. But as Branyo also mentioned, we run live demo webinars every Wednesday. So if you wanted to see Clover in a bit more action, in a bit more detail and CloverDX in action, then definitely come along to that one. I've shared the link for that one in the chat too. Let's see if we've had any more questions. Bear with me a second. Okay, so is there a doc that lists everything that CloverDX interoperates with? Example, Informatica for ETL, Irwin for data modeling, et al.
Okay, so the way Clover works is that Clover itself is a data management platform. So the ETL part is part of Clover. So we don't really need Informatica or anything else to do that, although we can. So, and the way we usually do this is through APIs, whether the APIs of the tool that we want to work with or APIs in Clover if we want to control Clover from outside. We do have documentation that provides documentation of those APIs, but of course we can't provide documentation for others. But in general, you can work with anything as long as it has standardized API, whether it's a REST API or SOAP or even something like Java or something like that. We will always be able to do something with it and to work with it in some way. And for tools like Irwin or similar data modeling tools, the typical approach is to grab a project from that tool, parse the results, and translate it in Clover directly into something else. It can either be Clover code as output, or something like a SQL statement for a database or something like that. It's really really up to you what you want to do. In this case, again, we can integrate with pretty much anything, but as I mentioned before, this is not out of the box solution. So there is nothing directly in Clover that has a button where it works connect to Irwin or something like that. We can do that, but it's a special implementation for every kind of a project because the projects are simply too different.
Brilliant, thank you, Branyo. A follow-on from Greg. Any docs on competitive landscape analysis, example CloverDX versus its peers in the same functional space?
Sure, we can have a look at something. We do have some materials in-house. I don't think we have anything on the website, but if you look around, for example, on aggregators like G2 and similar, you'll be able to find some comparisons there.
Okay, great, thank you. So a question from Brandon. Hello, I'm a recent graduate from Nashville Software School and I'm researching more about the data world. What part of the data team does a project like migrating data fall to? Is this more a data governance project or a more general scope data analyst project?
That's interesting question. It would kind of fall into both because usually as part of data governance, you figure out what you want to do with your data. And so data governance provides you the strategy. So people doing data governance in an organization might decide it's time to migrate something. They are not going to be the ones implementing that or maybe even driving the implementation on the business side, but they might be the ones to decide that, okay, let's now invest money into this. And then, of course, the data analysts, you will need them for building the solution. Usually they are involved at the beginning, either building the business specification and then often doing the technical analysis as well. They typically are less involved in the implementation and during the execution at the end.
Okay, brilliant. It seems that we don't have any more questions, and I think we've touched upon everything. So yeah, that's it. We'll wrap up for today. So thank you all for attending, and thank you so much, Branjo, for presenting. We hope to either see you tomorrow or next week.
Thank you, everyone, and
Thank
have a
you.
great
Take
day.
care. Bye-bye.
Bye.